Okay, let's get started. Welcome to my talk. I'm Jonas Helming, working for Eclipse Munich, and today I will present you a first version of our imagination of an app store for Eclipse Smart Home. I must admit I'm pretty nervous because I'm doing a live demonstration, and the stuff I'm presenting today is really a prototype. It's a conceptual prototype to demonstrate our ideas, so I hope everything will work right. Please be gentle if it doesn't. Mainly, I will do a demonstration. I would like to demonstrate our ideas, how we envision an extensible smart home system, but I would like to give a short background on our motivation and what we basically did before we dive into the demonstration. So we are users of home automation, also Eclipse Smart Home, and we like it a lot. We love it, actually. In the office, at home, wherever we can automate stuff, we want to do that. And we got in touch with different systems. There are a lot of different systems out there. And what we observed, that there are actually two directions a system can go in. First direction are those ready-to-use systems that you can just install, plug in certain devices, and then you have basically switches to turn off and on things. So those are those simple devices with one button or several buttons. I'm not saying those are bad, but we are software engineers. We want to have something more extensible where we can develop use cases and some logic. So for example, with those systems, it's easy, like Philips Hue, for example. If I want to turn on the light, that's easy. I can switch the light to a darker color. That's easy. But if I want to implement a logic like when I'm not at home, but I don't know, the cat is running on the balcony, that the light should go on, that's already difficult to do. On the other side, we have systems which are very extensible, like Eclipse Smart Home itself. But when you start to use such systems, you're already at the software developer area. So it typically looks like this. Also on the software side, you have to write software, you have to deploy it, and the configuration becomes pretty complex. There are some approaches in the middle, like many systems integrate if this, then that. That's kind of in the middle. But none of the existing system, from our point of view, is really extensible and usable by end users. And by end users, I really mean non-technical people. So, and our vision, what we want to have, is a system which is extensible by new use cases, also complex use cases, but still usable by an end user. That's our vision. We started to work on this project. It's a research project that we currently conduct, and our motivation is we want that system. We think that our technical background from the Eclipse area is a pretty good fit because we are experienced in building extensible system, modular system, and flexible system. It also involves modeling. And finally, we like to work on this project because it's a lot of fun. What I'm presenting today, so today is the first time I'm presenting this to anyone outside of Eclipse source. What I'm presenting today is our first prototype. The goal of this presentation is to find other people and get feedback about this approach. So if you like the approach, if you dislike the approach, I already invite you to talk to me after the presentation. Okay, so more details about our vision. We looked at other systems to find an approach which is extensible but also usable by end users. And a very obvious one is a smartphone. Smartphones are extremely extensible. You can install hundreds and hundreds of apps, but they are usable and it's proven by nearly everybody. Even children can install apps. So that's a good paradigm. So what we wanted to implement is something like a smartphone in combination with an app server for a smart home system. For a smartphone, it's not only the software that gets installed, but it's also wired to some devices. So a smartphone, for example, has a camera, it has motion sensors, and so on. So even the wiring is pretty much in parallel. So what's different? Why can we not just adapt the App Store or app concept for a smart home system? The difference is basically that every smart home, or every home is different. And there are two main things that it differs. We have different devices. When you look at a smartphone, most smartphones have pretty much the same hardware in it. So they have different cameras, but they at least have a camera. So for an app developer, it's pretty easy. You depend on camera, and then you can use it. For a smart home system, that is not true. There are smart home systems with only lights, some with only door locks, some with only motion sensors. So the available devices in every system are completely different, and that plays a role. If you want to develop an app, you need to somehow express what devices do you need. And the second difference is that we also have different states in the system. States are actually artificial states that are produced by either devices or software. So for example, a simple state would be the person is at home. Now, if you want to write an app which depends on that state, you somehow have to express that you need this information. A simple example would be an alarm app. So you can install it, and whenever you're not at home and a window is opened, an alarm turns on. But this app needs the information, is the user at home, which could be delivered by a device, by a button that the user can press, or by another app. So those are the main two differences that we identify. Another slight difference is that a home can consist of several floors, rooms, and so on, but that doesn't play such a big role when talking about apps. So our vision in a nutshell, so that's a simplified version. We want to provide an app store that's like a central repository where developers can deploy their apps. Every app realizes a certain use case. So for example, the most simple app would be a light switch. So you can press a button and a light turns on. And now every app describes its dependencies. So for example, an app could say, I need at least one light, I need, let's say, a door lock, and I need the information whether it's day or night. And that's done by the developer. So that's not already for the end user. Now, the end user who has a certain home can look at the App Store and identify apps to be installed on the system. So it's not like browsing scripts anymore in forums to implement use cases. You can really look at a list describing the use cases, and then you can install those apps on your system. During the installation, you have to bind the dependencies to the real devices. So you have to tell the system somehow, let's say the app needs one light. For example, the app could realize the use case, if I open my door, light turns on. The user somehow has to tell the app which light to turn on, because there could be several lights. So there is a binding process during the installation. Okay, demo time. Before we talk about the use cases, I will quickly explain the setup I have here. One disclaimer, when you look at other smart home presentations, they have much more fancy devices and much more fancy use cases. We kept it simple because we want to show the concept rather than shiny devices. So what I have here, you cannot see that, and I don't want to lift it. There is a Raspberry Pi here, and Smart Home is installed on that. This Raspberry Pi is connected over a wired network with a remote sender, Homematic. Homematic, through that sender, it can trigger a chime, which is over here, to play a sound. And it can turn on and off this light. There are two more devices connected to the system. There is a door sensor, which tells the system whether the door is open or not. And there's a window sensor, which tells the system whether the window is open or not. So that's everything. Not a huge system, but simple enough, I think, to get a feeling for the concept. Now I want to show three things. The first thing that I want to show is I will install a very simple app which has a dependency to a device, and I will show how to bind that. Then the second demo is I will install an app which has a dependency to a state. And the third demo will be how to write a completely new app and how to express its dependencies, because we already started to implement tooling for the system. Okay, let's switch over to the system. The system that what I forgot to tell is there are two more processes involved. So Eclipse Smart Home is running here, and what we see here is the local app system where you can install apps on, and which will then trigger Eclipse Smart Home to execute logic. So that's like the app runtime, which is running locally. And also, I have the App Store running, which is another server. Typically, it would be somewhere in the internet. In this setup, it's running on the same machine. So this local runtime, app runtime, will communicate with the App Store to install the app then. Now, what we see here is an overview of my system. We can see it's a simple home. I have a living room with lights, windows, and an alarm. So that's in the living room, and then I have a remote that's over here. It's not assigned to any room because I can carry with me, and this remote has 4 buttons. So, and those buttons have a name. This is actually all input for our system because we retrieved that from Eclipse Smart Home. Okay, so let's install a simple app. The first app I want to install is really the simplest one you can imagine. It's called the light switch, and it basically enables me to bind one of those buttons to this light. Very simple use case, but I think you get the concept from it. So I click on apps. Now I see the App Store. Down here, this list is now retrieved from the App Store. So I have 4 apps now in it. I select the Light app. We have a description. As you can see, the UI is not perfectly nice yet, as this is a prototype. But when I double-click this now, the system tells me now more details. Also, there could be a description. But the interesting part is down there, it tells me now to connect my devices, because the app describes what it needs. And this simple app needs a toggle trigger, the light switch, and the light switches. So let's wire that. I click on here, and now the system automatically retrieves all the possible things I could bind this trigger to. And those are exactly the 4 buttons on this remote. Now, there is one button named Key Light. That's this one. So I bind to that, and now I see on the left side with a green check mark, I have resolved this dependency. And now I need to bind it to light switches. At the moment, there are no light switches connected to the system, so this is not yet connected. So our vision is to start an auto-discovery here. So now the system searches for light switches, and now it found one, and now I can bind to this light switch. And thereby, I resolved the second dependency. And now I can install the app. The app is copied to the local runtime. It's already started, so we don't need any restart. And now comes the critical moment. Now, when I press this button, nothing special happened, but this light should turn on. So let's see. I press it. Here we go. OK, so looks very simple, but I actually added, during runtime, I added new logic to my system. Simple logic. We will have a more advanced use case now. Second thing that I would like to demonstrate is how you can depend on states. And states are not devices, but they are information which is typically produced by other apps. For that, I will install an app which is called Don't Leave Home Without. That's actually derived from a real example that we use at home and in our offices. The goal of this app is when you are about to leave your home, the app should remind you on things to do. There are some things that the app can automatically resolve. For example, turn the light off, because if you leave your home, you don't want to have the lights on. And there are some things that the app can, the system cannot resolve. For example, if there's an open window or, I don't know, the fire is on, then it should notify you that there's something wrong. So this app depends on the information that the user is about to leave the home. That could be bound to a motion sensor or something. In our case, we will bind it to a key. So whenever you leave your home, you just press that key, and then the system checks whether everything is fine. So let's install this app. So it's called Don't Leave Home Without. Now you can see there are 2 parts of dependencies. The first one are states. So it needs the information whether the user is at home or whether the user is about to leave the home. Now, I can bind this to sources now. What we see now is that there is another app called the Presence app, which can actually deliver this state. So the system tries to resolve the dependency. It knows at the moment this state is not already existing on the system, so it searches the App Store which other apps could produce this information. So I will take this Presence app. Actually, if we look at the is home state, there would be even another app which could resolve that, but the Presence app is a simple one. So I select this one, and now it takes me to the installation of the Presence app, which is now a prerequisite for the other app. The Presence app just needs 3 indicators. So that's the away indicator, so to tell the system that I'm not at home. I will bind that to the close lock button of this device. The about to leave, I will bind that to the door button, and the at home indication, and I will bind that to the open lock. And now I can install this. And now by installing this other app, you see that those 2 dependencies have been automatically resolved, because now those 2 states are existing in the system, so I don't have to explicitly bind them. And now I continue with the installation of this Don't Leave Home Without app. It needs an alarm because it wants to tell me if something is wrong. So I bind that to the chime over here. It needs to know about windows. I only have 1 window, but there could be several. And it needs to know about light switches because it's supposed to turn those off when I leave the home. OK, let's install the app. As you can see, I have 3 apps now. And now let's tell the system that I'm at home first. OK. Now, when I leave the home, I'm supposed to press this button, and then the light is supposed to go off. So let's press the button. Here we go. So that was now done by the Don't Leave Home Without app. Now, let me switch to I'm at home again. And let's turn on the light again. Now, I open the window. I'm at home at the moment. I open the window. And now I leave home again. So I press this button again, and then the chime should turn on because it cannot resolve the open window. So let's try this. Here we go. So now it tells me I cannot resolve this. That's all logic deployed by the app. So I close the window again, and then I leave the home again, and it just turns off the light. So that's now a little bit more complex logic, which is all deployed by the app. OK, so let's switch to the third demonstration, how to write such an app, because it might sound complex. So let's look at our first version of a tooling. So I switched to my Eclipse IDE. As you can see, I started the App Store and the app runtime from my IDE because it's under current development. And what I'm doing now is I create a new app in my IDE. So for that, we implemented a wizard. So here you can see I can create a smart home app project. I can give it a name. What I will do as an example is implement the alarm use case. That means whenever the user is not at home and a window is opened, it will trigger an alarm. So I would call that alarm app. Alarm app, and Jonas. Now, on the next page, I can define the requirements. And those are not OCI requirements, but the requirements to devices and states that are shown in the UI. So the alarm app obviously has a dependency to an alarm, because it needs to turn on the alarm if something is wrong. And that's an actor. That means we need to trigger the alarm. You can decide whether you want to allow multiple alarms. If you would have several of those chimes, you could ring them all. So I will make that multiple. I also have a dependency to window, because I want to check those windows, whether they are open. And I select multiple again, because there could be several windows. And finally, I tell the system, yeah?
Why was the external ring
because this sensor doesn't support so you cannot do something with the sensor. It's just a sensor. So I cannot trigger this sensor. It's just passive. It only tells the system the information whether the window is open, but the system can never do something back. That's why it cannot be an actor. Yeah, that's correct. In this case, so what we're doing, that leads to another interesting question, how this list is actually filled. So our vision is to build a central repository of types that you can use here as dependencies. And there could, of course, be a window which is also an actor, which you, for example, could close. But then I would probably use a different type here then, like a window, open, close, whatever. Yeah. OK, and I need the state is home, because I only want to trigger the alarm when the user is not at home. So let's click on Finish. Now, in our first version, so this bundle now contains an additional file. So it's a plain OSGI bundle, but it contains an additional file called AD. That's for app description. Technically, it's an EMF model, and it now contains those dependencies. It's not really important that it is an EMF model, but it's basically a description of the dependencies, pretty much like the manifest file for OSGI. We also generate a step to implement the app now. So let's have a look at that. To consume the states, we decided to use dependency injection because that's pretty flexible. And as you can see, it generated a mock where it injects all the states I depend on. So it's a Boolean whether the user is at home. It's a list of Boolean representing the windows, whether they are open or closed. And it's a list of on-off actors representing the alarms. So now I can implement my logic here. So the logic would be if the user is not at home and if windows, so the list of windows contains true. That means when the user is not at home and one window is open. By using dependency injection, those parameters would get re-injected whenever they change. So I would get an update. So in this case, what I want to do is I want to ring all the alarms. So what I do is I do a for each of the on-off actor, and then for every of those actors, I say turn on. That's all the logic I see. So, of course, this is still a very simple use case, but you can imagine that even more complex use cases would be pretty simple to write with this state-based approach. OK, so let's deploy this app. For that, I would just create an export manually from within my IDE. So I'm using that here, using a fresh directory. OK, now I go to the directory. It was 4, right? Yes. And I just take the jar and I copy it to the store directory. That's the directory which is watched by the App Store for new apps. Of course, in a productive version, you would have something like an upload mechanism or a repository or whatever, but I just copy it, basically. Now, let's go back to the running application. Now I open the app window again. I see down here it discovered the new app because it just had a look at the directory. And now I can install this app by double-clicking it. Again, I have the dependency, which is derived now from this AD file. I can see that the isHome dependency is already resolved because the Presence app is delivering that. I need to tell which alarm because I have 2 different options, either light or the chime. And I need to tell which windows I want to watch. I only have 1 window, and then I install the app. OK, and hopefully the final demo goes well too. So I'm not at home. And now, when I open the window, the chime should ring. So let's see. Here we go. Yeah. So that was the app just executed. OK, so I'm done with technical demos. I feel very relieved. And let's go back to the slides. As mentioned, this is currently really in the prototype state, but we are actively developing on that. Our next goal is to replace all the existing use cases that we already have in our offices and at home with apps. We started to do that. At the moment, we are very confident with the approach because all the existing use cases, even the more complex one, map very well to this concept. And the main thing that you can avoid, at the moment, we really have to copy scripts around and then rewrite those scripts if we want to transfer features from one system or from one room to the other one. And we are pretty confident that we can avoid this with this system. Of course, we plan to make this open source. At the moment, it's currently completely undecided where to do that. Maybe, so we would love to talk to the Eclipse Smart Home guys over there. But at the moment, this is too early to tell where this is actually going to be published. The main goal of this talk was to show this to the public, the idea. So I kindly invite you, if you liked it or if you dislike something, if you know that a certain use case would never work with that, or if you have an opinion about that, please feel welcome to join us at our booth, or send me an email, or get into contact with us over any channel. Besides that, I thank you for the attention, and I think I have time for questions, do I? Yeah. So are there any questions? Yes. That depends a bit. So the concept supports that you install the app either for the complete system or for single rooms, and it depends a little bit on the use case. If let's say you want to have an app which can turn all lights on and off, then you would just wire it to all the lights. If you want to have it per room, you would install it only in those rooms, and then you would have several installations of the same app. Absolutely. So that's the next thing that we want to do. So the idea is, I mean, for really running the system, you want to have a unified UI where you see states and you can even control the apps. So our idea is to provide a declarative way where apps can describe what they want to contribute to the UI. For example, they can say, I need a switch, or I want to display some text, or whatever. And then you have, at the end, you have a UI pretty much like you know from those smartphones, the widgets that you have in the home screen.